In this video, we're doing some basic definite integrals on trig functions. And remember, the fundamental theorem of calculus says all we have to do is guess the antiderivative of the integrand and then evaluate across the limits of integration. So really, the meat of each of these problems is guessing an antiderivative. In the first one, I have the integral of sine x, so I need to guess the function that I differentiate to get the sine function. And it's almost the cosine function. The problem with that is if I differentiate cosine, I get a negative sign. So I'm going to put a minus sign out in front to prepare for that. Now I'm looking at the antiderivative of the sine function, and then I evaluate that at the right end of the integration interval, giving me a negative cosine pi over 2, and then I subtract the result I get by evaluating at the left end of the integration interval. And the cosine of pi over 2, that vanishes, and then I have negative negative, in other words positive, cosine of 0, but the cosine of 0 is 1, and that one's done. In the next example, I have to guess the antiderivative of cosine, which is the sine function. And again, I evaluate that across the integration interval, and my first term is going to be the sine of pi over 2. Then I subtract the sine of 0, and the sine of 0 vanishes, and the sine of pi over 2 is 1, and again, I get 1. In the third example, I have the square of a secant function, and to get the antiderivative of this, you just have to remember what function do I differentiate to get secant squared, and it turns out to be the tangent function, so tangent x, evaluated from 0 to pi over 4. So I get the tangent of pi over 4 minus the tangent of 0. And the tangent of pi over 4 is 1, and the tangent of 0 is 0, and again, we get 1. And in our final example here, my integrand is the secant times the tangent, and you just have to recognize that that's the derivative of the secant function. And so I get secant pi over 4 minus secant of 0. And I have to remember that the secant function is 1 over the cosine function. And then I have to recall my special angles here. The cosine of pi over 4, that's 1 over root 2. But 1 divided by 1 over root 2 is the square root of 2. In the second term, the cosine of 0 is 1, but 1 divided by 1 is 1. So I end up with a final answer of square root 2 minus 1, and we're done with that one. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.